Welcome to this video on the decorator design pattern using Java. We will cover the concept, various use cases, and walk through a detailed example. The decorator design pattern is a structural pattern that lets you dynamically add new behavior to an object without altering its existing code. It achieves this by wrapping the original object with another object that adds the extra functionality, avoiding direct class modification or subclass proliferation. Common use cases for this pattern include Java I/O streams, adding features dynamically, implementing logging, security, or caching layers, and extending existing libraries. It is particularly useful in situations where you need to avoid subclass explosion. Consider a notification system starting with only email notifications. If new requirements introduce SMS, Slack, and push notifications in various combinations, using inheritance leads to a, quote, class explosion. The decorator pattern solves this by adding features dynamically at runtime. For implementation, let's use a coffee example. We start with a plain coffee class that has getDescription and getPrice methods. Initially, the description is plain coffee and the price is $5. First, we define the coffee interface with getDescription and getCost methods. Then, we implement plain coffee, returning plain coffee for the description and $5 for the cost. Next, we create the abstract base class coffee decorator, which also implements the coffee interface. It holds an instance of coffee to wrap and has a constructor to initialize this instance. Now we define the first decorator, milk coffee. It extends coffee decorator. The getDescription method adds, quote, with milk to the original description, and getCost increases the price by 2. Similarly, we create the cream coffee decorator. It also extends coffee decorator. This decorator adds, quote, with cream to the description, and increases the total cost by 3. To use the decorators, we start with plain coffee. We then wrap it with milk coffee and subsequently with cream coffee. The final output reflects the accumulated description and cost, demonstrating dynamic feature addition. Thanks for watching.